Scientific notation is something we definitely need to kind of talk about, because in chemistry we definitely need to pack up numbers in what we call scientific notation. In science and in other things, we oftentimes have very large numbers or very small numbers that frankly would not fit on the paper if we were to write all those zeros down. So, like I said, I use the word pack them up into this way of relaying what the magnitude of the number is using scientific notation. And scientific notation is otherwise called powers of 10. Another important aspect to packing a number up in scientific notation is you reveal a little bit about how you measured that number, how you came to understand that number. You relay something called the significant figures or significant digits associated with that measurement. And we'll talk more about significant figures, significant digits later. But again, if you pack it up, then you kind of relay that too. So writing a number in scientific notation always has two parts. It has what we call the coefficient part. That's to the left. And I'm just going to kind of, for now, write x.xxx, okay, where my x's are real numbers. This number over, so I said left, right, I meant left. Okay, so this number over to the left, this is called the coefficient. Okay, and like up here it says, it's a magnitude that is at least 1, but less than 10. That's our coefficient. And then we take it times 10. Oops, let me take a different color. We literally write the word times 10 raised to a power. Okay, and that power could be, I'm going to kind of throw a couple at you. What if it was 10 raised to the 5th power? Okay, alternatively, let's go ahead and just write, or it could be times 10 raised to the -3rd. How's that? -3rd. Now this part that I've done over here, two different kind of options to these different numbers. This is called the exponent part. Okay, exponent part, power of 10's part. So we have the coefficient part and we have the exponent part. Now I want to focus on what is 10 to the 5th and 10 to the -3rd. What do those mean? Okay, so the number 10 is really 10 raised to the 1st power, 10 times itself. The number 100 we could get if we took 10 times 10. 10 times 10, 10 times itself twice, we could say that's 10 raised to the 2nd power. What about the number 1,000? Of course, we could get 1,000 by taking 10 times 10 times 10. So if that's 10 times itself 3 times, that's 10 to the 3rd power. Okay, you're getting the idea. Just a couple more of those. 10,000 is 10 times 10 times 10 times 10 times 10. Wait, 10, anyway. 10,000, it's 10 times itself 4 times, so that's 10 raised to the 4th power. And then last but not least, 100,000 is 10 times itself 5 times. If that's the case, then we could pack that up into 10 raised to the 5th power. All right, now let's switch to the 10 raised to a negative power. Well, 0.1, you buy this, 0.1 is 1/10, okay? And 1/10 we would just write 1 over 10 raised to the 1st power. Now here's the catch. Well, I guess not much of a catch. Again, I'm not a math teacher, but if you have an exponent in the denominator and you want to go ahead and bring it up into the numerator, you have to change its sign. So that is flipped up in the numerator, 10 to the -1. Right? Okay. So 0.01, 1/100th, is 1/100th, and that's 1 over 2 raised to the 2nd power. If we bring it up, that's 10 to the -2nd. So you know where I'm going with this. Okay, 0.001 is 1/1000th. 1 over 10 to the 3rd, that's equal 10 to the -3rd. How many more of these I got? 2 more. 0.0001 is 1 over 10,000. 1 over 10 to the 4th. Bring that up to the numerator from the denominator, and you have to make it -10 to the -4th. The last one I have here is 1 over 1/100th. Well, excuse me, 1/100,000th, final answer. So that's 1 over 10 to the 5th, and so we bring that up, that's equal to 10 to the negative 5th. So we're going to use those actually momentarily to pack up numbers in scientific notation.